Thank you for attending my presentation at the Product Focus in ECOC 2021. My name is Young Sun, the CTO and CMO at Optomind. I'm so delighted to present our true PAM4 AOC for huge volume deployment as an optical interconnect solution in the advanced data center today. Based on famous Cisco research on Global Cloud Index, over 80% of data traffic is generated within data center in North America. Total east-to-west traffic is over 90%, and it means shorter reach interconnect is driving more data traffic than longer reach. Traditionally, rack local traffic is governed by DAC, copper cable only. As data rate increases beyond 50 gigabps per channel, and 8 channels of form factor such as QSFP-DD becomes popular, cable management and handling within the rack becomes a nightmare very seriously. Thick copper cable is too heavy and rigid to handle, and thick to block the airflow very seriously. Advanced HPC systems already started adopting AOC for top of rack as well as rack to rack interconnect to overcome the cable issue. Light counting presented market for Ethernet and DWDM optics at OIF last February. One interesting slide shows the same as the Cisco Cloud Index result. Most data traffic through optical cable is between 100 meter and 2 kilometer. If we narrow down it to high data rate only, like aggregated 100 gigabps and beyond, far more optical bandwidth will be used within shorter than 100 meter. That area becomes a sweet spot of the market with AOC adoption more and more. Another interesting result on total cost of network connectivity from Cisco. As you see, the portion of BOM cost becomes larger for optics as the data rate goes faster. It is natural that reduction of network hardware cost is decreasing much faster than cost of optics. Optics complexity and its nature of signal integrity at higher data rate make it happen, especially at 400G and beyond. Optics technology shall require more cost innovation in volume production to satisfy huge market demand coming this time. Direct driving current modulation of VCSEL with PAM4 signaling is more difficult than electro-absorption type modulation of laser diode to make a good optical signal. DSP is an approach to get better signal performance of PAM4, and it is popular in the market. DSP consumes more power than analog CDR and requires longer latency, which is not desirable for HPC, AI, and machine learning application. Analog CDR is viable solution in PAM4 SR product, but it is not popular in the market yet. We should consider complexity of multiple parameters in designing VCSEL-based optical link in PAM4. Multimode high-speed VCSEL has various beam profiles, including beam divergence and spatial mode distribution. Optics design requires to receive all the beams from the VCSEL to transmit high-quality PAM4 signal to receiver. Direct modulation of VCSEL for PAM4 signal requires maintaining linearity for the operating temperature range. PAM4 optical signal performance is influenced by various parameters including RIN, spatial mode partitioning noise, optical feedback, and crosstalk. We should consider how these parameters can be minimized in optics design. Optomind has a very unique optical engine with its own optics design using individual VCSEL and PD. We achieved outstanding results from the design for the following. Negligible optical crosstalk between channels, which can make lower optical noise from neighboring channel. We could optimize optical coupling for all channels and get stable optical coupling for wide range of temperature. Bigger lens diameter can make better quality beam and smaller spot size at fiber facet. Then we could get longer transmission with OM3 fiber by lowering the model dispersion. Single VCSEL could expect longer lifetime than array, which will extend optical module lifetime and save maintenance cost in data center operation. Individual VCSEL and PD die is mounted on the PCB at the pre-aligned position using commercial die bonding machine. OSA is attached to the aligned PCB to get optical coupling between VCSEL and lens. Customized ribbon fiber is inserted into OSA by translation with a simple mechanics. Coupled optical power is monitored using GUI and fibers and fixed to finalize the assembly. Our direct plug-in fiber modular coupling method for high volume optical assembly does not require any high precision alignment equipment owing to the self-aligned assembly architecture, which renders a fully passive self-alignment. We have achieved remarkable alignment tolerance with smart optomechanical engineering. We implemented 400G QSFP56DD AOC with 2 units of 8-channel OSA and analog CDR based chipset. We implemented 400G SRA transceiver with 100 meter OM3 fiber and measured BR and burst error for 14 hours. The maximum BR was 10 to the power of minus 11th and the maximum burst error code was limited to 3 at 1 channel only. Our 400G SRA transceivers can reach up to 150 meter OM3 standard multimode fiber at 70 degrees C without problem. The maximum BR shows still 10 to the power of minus 9th and average BR maintains 10 to the power of minus 10th or lower. Our new optics design enabled the progress at high temperature and longer lengths of the fiber without significant degradation of signal integrity. We tested our SR modules with a commercial 400G switch to validate real working environment. The samples are put inside the chamber together with the switch as shown in the slide. We chose the ports at the edge of switch, which has the longest electrical length of interface from the switch chipset. No error of uncorrected cold words with temperature cycling found at endurance test over 17 hours. We succeeded to get an excellent result with the commercial DSP version SR8 module in interoperability. We measured the actual power consumption and BR of 400G AOC with Keysight 400G tester to compare between analog CDR and DSP under the same operating condition. The cable lengths of AOC for analog CDR and DSP were 100 meter and 10 meter respectively. The result showed 21% lower power consumption and a better BR of 1 or more order of magnitude with analog CDR 400G AOC relative to DSP AOC. We tested 400G SR8 transceivers using 400G tester. Measured pre-FEC BR was 2.2 times 10 to the power of minus 8, and there was no more than 2 symbol errors per code word for 100 meter OM4 fiber loopback. We tried link testing of 400G QSFP-DD AOC with a commercial 400G switch. We obtained a link up for all 32 ports without any problem. The maximum pre-FEC BR for the worst channel was in 10 to the power of 9th range. There was no FEC uncorrected code word for all 32 ports. We tested several interoperability items with the commercial switches and NIC cards to confirm the compatibility of 400G module. We tried 400G and 200G AOC to multiple switches and NIC cards in the list. There was no issue found from the testing. 200G QSFP and 400G QSFP DD products are in production for both AOC and SR transceivers. SFP and DSFP AOC is ready for pilot production. Any combination of breakout AOC is available. Our breakout AOC does not include ugly fan-out junction. We have best-in-class PAM4 AOC solutions as a flagship product, including QSFP DD, QSFP, SFP, and their breakouts with flexible combination of each form factor. We are doing the same with 25 Gbps energy products for both AOC and transceivers. Our transceiver can reach longer than standard SR specification with OM3 fiber and cable attached transceivers are attractive to highly dense and complex routing of end-of-row or middle-of-row application with a patch panel deployment. I would like to summarize our approach and current status in PAM4 SR module and AOC. We designed and implemented SR module and AOC to meet all standard specifications. The following are the key features of our optics design. Our new optical engine has demonstrated an excellent SRA transceiver performance in PAM4 56 Gbps per channel as a result. Optomind is ready to support HPC and hyperscale data center applications with its PAM4 AOC and transceivers. The products are deliverable to customers now. If you have any question or inquiry, please contact me anytime. Thank you for your attention.